Hi folks, welcome into Beyond the Briefing. I'm jpdice. I am an airline transport pilot, flight instructor, and a 26-year veteran of meteorology. Been doing weather on TV for a long time, and I love talking about aviation weather and how it could help make you a better pilot, safer pilot, and also what we can do to help you pass that private pilot check ride. There is a weather component of that. Perhaps not enough weather in the private pilot check ride. We want you to stay out of trouble. We want you to be safe, and we also want you to pass that private pilot check ride, the oral portion. So let's get right to it. This is my check ride guide to weather, and my oh my, that is a thunderstorm that you would not want to be flying into. Look at that thing, pretty ugly out there. It sounds crazy, but believe it or not, you look at the NTSB reports, there's folks that fly into things that look just like that. The results typically are not good, as you might imagine. So we want you to stay out of that kind of weather, understand how that weather develops, where it develops, how long it lasts, and what to look for. What I always tell people, what you don't know can kill you and your family. As with anything, there's a lot of things we believe we know, but we really don't know what we don't know. If you think about that, you suddenly realize as you fly longer and longer, there are things that you may have kind of escaped or gotten through, and the end result was okay, but many people have not been as fortunate. So there's some basic rules that we're going to share with you in this presentation on how you can be safer when flying, especially general aviation aircraft. Sources of weather information. More now than ever and better than ever. That's the nice thing about all of this. We have some fantastic weather data available to us, and it comes in the form of ASOS. That's been around for a while, Automatic Surface Observing System that the airports have. When we show the weather on TV, it comes from ASOS or AWOS station. NEXRAD radar, this is our network of Doppler weather radars that have been around for a number of years now. The network really completed in the late 90s, early 2000s. Great tool to detect rain, severe weather, snow, just about anything. And then our GOES satellites. The GOES network, the GOES satellites have really been upgraded over the last couple of years. Tremendous amount of satellite resolution. And we incorporate that in when we're trying to do our flight planning. I don't think as many people look at satellite data as we probably should have them using, but great tools there, and most of this, if not all of it, is readily available online or in some of your popular EFBs, electronic flight bags like ForeFlight and Garmin Pilot. So make sure you are incorporating this into your flying, not only as a student pilot, but also as an experienced aviator. What is ASOS? Automated Surface Observing System, and it does have a closely related brother known as AWOS, Automated Weather Observing System. AWOS stations are typically at smaller airports. I'm in the Birmingham area, so Birmingham Shuttlesworth International Airport, KBHM, where my airplane is based, we would have an ASOS. Some of the satellite airports like Talladega, Pell City would have an AWOS station, both doing very similar things, producing the METAR essentially. Visibility sensor, this is what makes up this instrumentation to sense whether or not it's 1 mile, half mile, 3 mile. That visibility sensor is basically looking for clouds and being able to detect how far it can see. It's a pretty neat thing, the visibility sensor. It can be fooled sometimes if you have fog that kind of moves in and settles in right around the ASOS station, but it is a good tool to, when you call up and listen to it on frequency, or you're calling on the phone, maybe you're on the ground checking out the conditions at the airport, or you're checking in your ForeFlight or Garmin Pilot or one of the other popular EFBs, let you know what the visibility is. Visibility is always in statute miles. Remember that, always in statute miles. Sometimes they try to trick you up a little bit, but it's always going to be in statute miles. And if you see something that says P6SM, that means greater than 6 statute mile visibility. You may remember that from the written test. The ciliometer actually fires a laser and looks for it to bounce back, and that's going to determine the ceiling, where the lowest cloud base is over the ASOS or AWOS station. Also can be fooled sometimes if you have a cloud that kind of parks itself over that particular unit. Again, something else to remember, ceilings are always in AGL, not MSL, AGL. Just about everything else in aviation is in MSL, but ceilings are in AGL. So if you have a 500-foot ceiling, that is 500 feet above the ground. Precipitation identifiers at hail, sleet, snow, rain. Rain sensor, is it raining? Not all of the systems have a rain sensor. Many of them do. And then you have our wind instrumentation. You have a weather vane or a wind vane and an anemometer. Sometimes this is combined on some systems where you have something called an aero vane. And it looks like a little propeller on the end of the weather vane. And then on other systems, you don't have any moving parts. You have an ultrasonic instrument that is going to be able to detect the wind speed and the wind direction. And the wind speeds are in knots, of course, and the wind direction, that's going to be the direction in which that wind's coming from magnetically. So if you have a 180 wind, that wind is coming in out of the south. So be aware of that. Some little tricks there that you may not always remember. Let's talk about ASOS. It's where METARS are born. KORD. By the way, you know what KORD is? If you're not familiar, we could do a whole program on these identifiers. That's Chicago O'Hare. Just like MCO, you go down to Disney World and you land at MCO, that is McCoy Air Force Base. Some are pretty easy to figure out, like TPA is Tampa, MIA is Miami, but some are kind of interesting where they get their name. So this is a METAR, and on your private pilot Checkride, the oral portion, most likely the examiner is going to want you to decode this thing. They're usually in plain English on the EFBs and on the websites these days, but they are coded as well. Why are they coded? Why were they ever coded? Here's why they were coded. Back in the days when we had very low transmission speeds, low baud rates, if you remember that term, any computer junkies, you had to transmit a lot of information coded because you needed to get it there quickly, and if you used all these extra words, it would take longer and kind of bog down the system. So everything was coded. That's why you have coded METARS and TAFS. That's kind of the backstory on that. The bandwidth, so to speak, just wasn't there. So here's the translation. 24th day of the month, 1651 Zulu. Know your Zulu times, by the way. Winds 1806 knots, so winds out of the south at 6 knots. 8 statute mile visibility, few clouds at 1,000, broken clouds at 3,000, overcast at 5,000. It's a VFR day. Altimeter 30.07. Altimeter is nothing more than a barometer, and that remark is A02. That means it's automated with a precip sensor. If it was A01, it would mean it did not have a precipitation sensor. There's some various remarks there. If it has a dollar sign, it means the system needs maintenance. A lot of different things that are coded in there, but really what you're mostly concerned with is the ceilings, the winds, and the visibility. That's what most of us are concerned with. Or if we have rain, sometimes it will say CB. That means cumulonimbus, things like that. So keep that in mind. But METARs come from the ASOS. You have your hourly METARs. What are the TAFs? Now the TAF is a terminal aerodrome forecast. Don't use the MOS, folks, okay? We talked about that before in a previous episode. When you're really doing your die-hard flight planning, the MOS goes out longer period of time, but it may not be correct. It is computer-generated data. It means model output statistics. Don't be confused. The TAFs are issued every 6 hours, 4 times daily, 12Z, 18Z, 0Z, and 6Z. Valid for up to 24 hours. They include wind, ceiling, visibility, rain, thunderstorm probability. They are created by meteorologists at the National Weather Service. So your local National Weather Service office is actually producing that TAF. Here's a TAF from Oklahoma City. And what you break it down to is the different components of the TAF. One is the type of report. Okay, that's the TAF. The ICAO station identifier. And that's going to be KOKC, Oklahoma City. Date and time of origin. So that's going to be the day 5, and that's going to be at 11:30 Zulu. Okay, not 11:30 a.m., but 11:30 Zulu. And we're going to be looking at 12:12. So that's going to go. It starts. It's valid from 12Z on the 5th to 12Z the next day. So that's what we're looking at on the TAF. 5 statute miles. We got some BR. What's BR? That's mist. You know how I remember BR? Baby rain. Baby rain, BR. Broken sky there at 3,000 AGL. And then we have a temporary condition. Conditions are expected to change between 13 and 16 Zulu. And that's going to be 1.5 statute mile with more baby rain or mist. And then it has a from group. And that from group is the weather after 16Z. Wind direction is 160, 10 knots, greater than 6 statute miles, and the sky is going to be clear. So you have to know how to decode that TAF. A number of guides on the internet to decoding TAFs. Hopefully that helps you out a little bit to get started. The TAF, again, is a forecast that is put together by human hands. National Weather Service meteorologists have put that together. It's not just some data that a computer spits out. NEXRAD radar WSR-88D. These are fabulous tools. You see them all the time when we're tracking storms on television. They produce very high resolution data. You're not always able to see that high resolution data on some of the electronic flight bags. I suggest getting another app like a radar scope so you can see the 1/4 kilometer resolution, the super high res stuff for that. NEXRAD means Next Generation Doppler Radar. WSR, Weather Surveillance Radar 88, was when this was developed, 1988. They weren't fully installed across the U.S. until late 90s, early 2000s. And the D stands for Doppler Radar. It's a volume scanning radar, starts at the bottom, goes all the way around, antenna tilts up, goes all the way around, and tilts all the way up, like 14 different layers there to get that data. The volume scan gives us a lot of extra data as meteorologists, but usually as a pilot, you are interested in that 0.5 degree, that lowest tilt elevation, to give you an idea what's going on. But this is how the echo tops are produced. It's the radar tilting all the way up to give you the top of those thunderstorms. Echo tops is a handy feature of the radar, and it's a parameter you can look up online or on the electronic flight bags like Garmin Pilot, and also on 4Flight. We can get an idea how tall are those thunderstorms. Limitation of radar. You know, you can have a zillion watt power radar with a 50-foot antenna and all of this stuff. It's only going to reach so far, and that's because despite the beliefs of a few online, the Earth is round. Little humor there. The Earth is round, and what's happening in this example, if you had a thunderstorm somewhere between Montgomery and Birmingham, the two radars would shoot right over it because of the curvature of the Earth. The farther you get from the radar site, you're looking up higher in the sky, and you could be looking up over the rain or the thunderstorm. So when you're looking at radar information, always choose the radar that is closest to the area that you are trying to evaluate. Now on 4Flight, that's all composite data. That takes all these NEXRADs together and kind of meshes it together. That gives you a pretty good picture of what's going on. But again, remember, it's not single site data, so it's not going to be quite as high res as what you would see on radar scope or something like that. All of the data on XM in the cockpit or ADS-B, that is composite data. Just remember that. And there's a time delay. Make sure your examiner knows if you're using in-cockpit weather that you realize there is a latency that could be anywhere from 4 minutes to upwards of 10 minutes, maybe even a little bit more because of the processing and that transmission speed. So I want you to realize the limitation of radar. Radar is a fantastic tool, of course, as you fly more advanced aircraft that have the radars built into them, either in the little pod under the wing or in the nose cone. You can look at real-time data. Those radars also have some limitations, but when you use it in conjunction with NEXRAD, it can provide you a wealth of information, real-time as well as ground-based data. That's the best of both worlds. Most of us, of course, in general aviation aircraft do not have those capabilities. And the GOES-R satellite. Probably the least used of all weather data available to us. If you're looking for a clearing line, for example, a clearing line on a map during the day, don't go for the infrared satellite imagery. Use the visible. The infrared could be tricked because it is looking at warm clouds versus cold clouds. You're going to find the detail as far as a clearing line with the visible satellite data. You can't use visible at night, though. You have to use infrared. So that's the limitation of visible satellite data. Visible satellite data is like taking a camera, a really nice camera, putting it up there about 24,000 miles up, and taking a picture of the clouds. So visible data, that's your best bet if you're trying to find a clearing line out there. You can get the satellite data, of course, online. You can get it also Garmin Pilot, ForeFlight, some of the other EFBs out there. Which one happens to be your favorite? Pick one and you'll have that data available to you. All right, where do you get all this information? ForeFlight, Garmin Pilot, one of the other EFB applications that we like to run on our tablets. 1-800-WEATHER BRIEF, you can get that over the phone, old school, a mobile app, or the website. Aviationweather.gov. Always check the weather before you fly. This is non-negotiable. You can't go up in the sky, even if you're going to go just to putter around a little bit. Check the weather before you go. That is critical. Some people don't do that, and it bites them. I'll give you an example. So it's a sunny day, and you're going to go fly. I'll give you an example. It happened to me. Sunny day, beautiful day, go to fly. And I knew it was going to be a sunny day all day. Didn't check the weather that much. And when I got back, the winds were gusting over 25 knots. And it was pretty much a crosswind. And at that time, I had about 50 hours. Obviously, that was beyond my capabilities as a private pilot. The landing was sporty, nothing was broken, and everybody was okay, but I could have done a better job. Don't get yourself in that pickle. Ask yourself, what are the winds? What are the forecast winds? What are the ceilings? What are the forecast ceilings? You don't want to go VFR into IMC by accident. That does happen. Are we expecting hazardous weather? Any kind of rain, snow, precipitation, icing, thunderstorms, plus how about the airport NOTAMs? You get there and you're flying to your favorite destination and the airport is shut down because they got some government funding and they decided to repave the runway and you didn't look at that. So always look at the NOTAMs. This is a neat little chart. The FAA and the FAST team, they have been really showing this chart. If you go to some of their website, FAA websites and the FAST team pages that they've put out there, this is pretty nifty. This is a VFR analysis worksheet, and it kind of forces you to fill this information out to know what you're going to be getting into. And what they want you to do is be thinking about this. I know most of us, we want to hop in a plane, crank it up, and go somewhere and forget all this crazy paperwork. But you know, the airlines, they have all of this weather information when they go somewhere. Most of your charter operations and even your corporate aviation operators. That's why they have a great safety record, because they're thinking about this stuff. It's really important to know what the wind speeds are. Notice it says right there, your personal minimums. We all need personal minimums. If you don't have personal minimums, you're going to get yourself in trouble. That means the airplane may be capable of handling it. Are you capable of handling it? And if you're not, do you want to find out when you're on short final? Probably not. Not the best plan. We find ourselves there every now and then, and that's something that we do try to avoid. All right, let's talk about this. This is a neat thing. This is called a prog chart. PROG is short for prognostication. A PROG is a forecast, and you can look at these PROG charts, and they go out 24 hours, 48 hours, several days out. It's a forecast map. It's kind of like the old school weather map we used to show on TV. When I was starting in TV, we had a national map. We had all the fronts on there. We don't do that so much anymore, but that's what this is about. They used to be in black and white too. We called them DIFAX charts. Now we are colorized. And simply said, this shows you frontal positions. It shows you where there's going to be rain, where there's going to be snow, and a human actually drew this. This is actually produced by meteorologists, and you can look at this. I'll look at mine on 4Flight. You can look at it on the aviation weather page, the government aviation page. This is from NOAA, National Oceanic and Atmospheric Administration. Your examiner during the check ride is going to want you to be able to tell he or she what kind of fronts these are. Are these cold fronts, warm fronts? Be able to identify everything on the map. And those little bitty faint lines, those are called isobars. Those are areas of equal pressure. All right? High and low pressure areas, be able to identify that. There's a lot of weather in aviation. As I mentioned, there's probably not enough. This is just to get you by. This is a low-level significant weather chart. This is interesting. Your examiner probably is going to have you look at these because there's different symbols on this that's going to let you know if it's going to be VFR conditions or IFR conditions. Notice in red, that means the ceiling, I'll take this up full screen, is less than 1,000 feet. And the visibility is less than 3 miles. And then you have 1,000 to 3,000 feet. In the blue hatched area, that's going to be your marginal VFR. Then you're also going to be looking at moderate or greater turbulence. So look at these charts before you go somewhere. Look at the TAFs, look at the charts, look at the frontal positions. If you're planning a trip, look at all of this when you return. Are you going to be able to get back from that trip? A lot of information out there, and again, human hands actually put this together, so it's pretty nifty stuff. This is called a station model plot, and the little circles there, that is from AWOS and ASOS, and there are these things all over the country, these little circles out there, and you've got red for IFR, you've got the blue for marginal. In fact, my little METAR map back here has the same color codes, just like the FAA. And then you have the green for VFR. These station model plots, if you look at them and you zoom in real close, this is what it looks like. It's showing you the wind. So the wind in that case is out of kind of the northwest, and that's going to be a 15-knot wind. If it has a flag on it, the little triangle, that'd be a 50-knot wind. What we're looking at there is 10 plus 5. So that's that barb is 10 knots, and the little half barb is going to be 5 knots. It's going to give you sea level pressure, temperature over the dew point. Remember, if the temperature and the dew point are together, you know what the answer is. It's either going to be raining or you have low visibility. As the temperature is warm during the day, that temperature dew point spread increases and the visibility gets better. That's why we often have fog during the overnight hours, early morning hours. We typically do not see fog at 2 o'clock in the afternoon because of the temperature and the dew point spread is too far apart. And the little circle in there, if it's a clear sky, it's an open circle. If it's overcast, it's going to be filled all the way in. And you see the little dots there indicating rain. That's the type of weather. There's actually 99 different symbols for weather. You can't remember them all. But look up the big ones like thunderstorm, snow, rain, that sort of thing. Fog, which is going to be like 2 parallel lines. We used to have that on one of our weather maps on TV, and I made them change it because most people, it's like, what symbol is that? The general public didn't know. But very handy to know this information. Airplanes tend to fly better when you have high pressure instead of low pressure. That's because the density of the air, the molecules are closer together. Pretty handy information to know there. Also, density altitude. Understand that concept. The higher the density altitude, the less the airplane is going to perform. You can hear that on your AWOS, ASOS stations, even when you're getting it over the radio, over the telephone, or if you are looking at it on an electronic flight bag type application. All right, this is cool stuff right here. I enjoy teaching this. High and low pressure systems. So what kind of weather is produced when you have the big H. You know, sometimes people think that big H means hot. It has nothing to do with heat, not directly anyway. High pressure is sinking air. You can't have a cloud form when the air is sinking. So notice on the graphic you have very few clouds over there. When you have low pressure, the air is rising. As the air rises, it cools and it condenses and reaches a level called the LCL, the lifted condensation level. That's when the temperature and the dew point meet and you have the clouds start to develop. So low pressure is when you have rain, clouds, kind of yucky weather. High pressure is going to be sunshine. Better days to fly VFR, obviously, that's going to be your high pressure days. Where are the winds the highest? Where are the winds the highest on this particular map? Let's look at this real hard. Do you see the isobars? You see the isobars off the coast there of the mid-Atlantic? That is called a tight gradient, tight pressure gradient right there. That is where we are looking at very high winds. In this case, that's probably a tropical storm or a nor'easter or something like that, where they are so tightly wound. But anytime you see the isobars close together, that is where we are looking at high winds. So if you're planning a flight and you see your location with isobars packed tightly together, it's going to be very windy. In that case, since the pressure changes so rapidly over a small geographic area, you're probably looking at 50 or 60 knot winds in that particular example. Let's understand cold fronts. All kinds of cold fronts that you're going to have to identify, or all kinds of fronts in general. And what we're looking at right there is a front. Can you pick it out? I can. It's that linear kind of formation of clouds over Florida going up the Atlantic all the way up to the northeast. Behind it, high pressure builds in, and you have some sunshine. Pretty easy stuff, right? So the cold front, there it is. See those little barbed, we call them pips and barbs. Barbs for the cold front, they're called pips on a warm front. Just a little weather trivia there. But that is the cold front. Easy to analyze even on a satellite picture. And the big blue H, I didn't put it on the map there, but the big blue H is right behind that. And that is where the high pressure is building in. Cold front is going to be colder air replacing warmer air. And this is the explainer. Advancing cold air behind the cold front. The little triangles show the direction of the movement of that front. And ahead of it, what it's doing, it's kind of like a bulldozer. It's lifting up that warm, moist air. And as it does that, those clouds are forced to develop into sometimes thunderstorms. They grow in vertical development. A lot of times with the cold front, not always, but a lot of times with the cold front, that's where you have really tall, you have really vertically developed clouds that can cause trouble if you are trying to aviate. Understanding warm fronts. Warm fronts are typically a little tamer. However, with a warm front, you can sometimes have some cellular thunderstorms develop ahead of that warm front. The warm air is replacing the colder air, but most of the time, warm fronts are going to give you stratus-type clouds. You're going to have light rain with a warm front. It's going to be kind of a soggy day, not necessarily volatile, but it's going to be rain, sometimes even some snow, depending on what the temperature profiles are. And there's the one that just won't go anywhere. This is called the stationary front. They're battling it out. The cold air can't move forward and replace the warm air, and the warm front can't move to the north, in this example, and replace the cold air. So they just kind of stay parked. And those are the situations where you've been sitting around wanting to fly somewhere, and every single day, oh my gosh, it's rainy and cloudy. The next day, oh my gosh, it's rainy and cloudy. Will this ever clear out? That's your stationary front. They're a little bit of a pain, but you can get some pretty nasty weather along a stationary front. You can get some thunderstorm activity, so keep that in mind. And then we have one that sometimes confuses folks. It's called the occluded front. It's the purple one. And that is essentially a cold front is catching up with a warm front. You have rain and thunderstorms. It's usually right there around the low pressure area. In this particular case, if just showing you this graphic, the winds out of the north would be behind the cold front. underneath the cold front and the warm front, you'd have more of a southerly flow. And remember that low, the flow is counterclockwise, at least in the northern hemisphere, and that's because of the Coriolis force. Differential heating causes pressure systems to form. All right? How many times have you been flying along in your low level, say 2,000 or 3,000 feet, kind of puttering along? Maybe you're in the pattern or something, and airplanes just jolting all over the place. Well, that's because the ground heats up differently in different places depending on what the ground is composed of. It's really the albedo, so to speak, of the different surfaces. So, which is going to heat up more rapidly, a parking lot or the forest? The parking lot. So the parking lot, you actually get these thermals that come off the asphalt there, or even the tops of some buildings like a Walmart or a Home Depot, some of those bigger buildings. And you don't have quite as much heat coming off the forest. So what ends up happening, you have differential heating, and that ends up forming these little pressure areas, high pressure and low pressure, and you have the thermals lifting you up. When you fly gliders, you'll learn a lot more about this. But high pressure always flows to low pressure, so you can even have like these little micro scale winds that happen because of these pressure differences and the differential heating. This is why sometimes you will even see an initiation point of thunderstorms along a highway. It's also why you sometimes see that line of clouds that forms right there at the beach, because the ground heats up more rapidly than the water does. Also why you have the sea breeze. The ground heats up rapidly, you have the low pressure rising, the high pressure off the water moves to the low pressure, and you get the sea breeze. It reverses itself at night. This is why when we go to the beach, the land, we're always plagued with some gusty wind, is because of the differential heating. So the next time you're fighting that crosswind at the beach, you can say, that darn differential heating is messing me up again. Stages of thunderstorm development. When you really have to be concerned is the mature and dissipating stages. Mature and dissipating stages are concerning because you have higher winds, severe turbulence can happen. You can have these updrafts inside a thunderstorm growing at 6,000 feet per minute. That's a heck of a ride that you don't want to be in. Hail can form, and during that dissipating stage, that's when you have that highest potential for microbursts to happen, which can really plague you when you are on final into an airport and you have that tremendous change in headwind to tailwind and a loss of lift. So be aware of that. The stages of thunderstorm development. By the book, we're supposed to stay 20 nautical miles away from a thunderstorm. Is it always possible? No. You do the best you can. It's pretty hard to measure that all the time. But again, especially VFR, if you stay 20 nautical miles away from the thunderstorm, you're going to be in good shape. Ultimately, you'd like to get above them if you were in a jet aircraft, or if it's going to be a terribly stormy day, you're better off on the ground. So we want you to be safe there. If it's going to be one of those days where you just see cumulonimbus clouds all over the place, best served to stay on the ground. But the book says 20 nautical miles. You tell that examiner 20 nautical miles is how far you need to stay away from these pesky thunderstorms. Let's talk about air mats. Air mats are issued for less severe weather that usually impacts smaller aircraft. They're valid for 6 hours. Let me give you an example of an air mat. That's going to be moderate turbulence and icing, like light to moderate rime ice, something like that. Surface winds, 30 knots or greater, restricted visibility. You have several types of air mats, and you have it for Tango, that's turbulence, Sierra for visibility issues, and you have it Zulu, Air Mat Zulu, and that is for moderate icing. So those are the air mats. They will show up, again, on your electronic flight bag, on those apps. It will show up if you've got a G1000 and you're on the weather page there. They will pop up. It will show up various places. If you call 1-800-WEATHER BRIEF, they're going to tell you. But you know what? That in-cockpit weather is great because it's going to show you right there on the map what's going on. SIG mats. Now, SIG mats really get my attention because they can cause some very big problems, not only for someone in a Piper Cherokee, but even pilots flying a 777. They impact all aircraft, significant weather, non-convective examples include severe turbulence. If there's a SIGMET that pops up and the pilot's going to have to, get close to that or go through it, this is when that seatbelt sign is going to come on. Even dust, sand, or volcanic ash. That's a non-convective example of a SIGMET. Convective examples of SIGMETs include thunderstorms, squall lines, surface winds greater than 50 knots, and even tornadoes and hail. SIGMETs are a big deal. If you see a convective SIGMET pop up, that is not where you want to be. Now remember, if it pops up, it may not be happening right now. That's going to be a convective SIGMET for maybe a little bit later in the afternoon. It's something that you need to watch. But again, know the time frame that the SIGMET is valid for, and just realize these are big deals to all types of aircraft. We have something else called a convective outlook that we look at. I've been looking at these for ages in the television weather business. And they used to be, in my opinion, fairly simple. It was C text, very simple C text. It was slight, moderate, or high. A few years back, the folks at the Storm Prediction Center thought they'd make it better. I don't know if they did. I think it gets a little bit more confusing, but you have general risk of thunderstorms. You have marginal, which is isolated severe thunderstorms are possible. You have slight, which is scattered severe thunderstorms are possible. Enhanced is pretty significant. If we get an enhanced risk, that is a big deal. Moderate and high, obviously, are your big, typically high wind and tornado days where you have a lot of damage. But even a marginal day for someone in a light aircraft, that can be impactful. A general thunderstorm risk can even be impactful. So understand these risk areas. Here's what they look like on the map. That's your convective outlook. And this one I included because it had an example of everything there. Over North Dakota and South Dakota, down through Nebraska, that is just a general risk of thunderstorms. The high risk, not a good day for the state of Alabama. That's where we have some pretty serious severe weather. No one would be flying, or they shouldn't be flying in that kind of weather. That's just going to be a nonstop severe weather, one storm right after another, probably tornado producing kind of setup. But when you're in the enhanced risk, that can be a pretty nasty day as well. These things go out, the convective outlooks. You have SPC day 1, 2, and 3, again, available on your EFBs, your electronic flight bag. So hopefully all of this information helping you out there to be the weather expert for your private pilot check ride. It gets a little bit more detailed for your IFR ride, but I really wanted to address this for the private pilot students and even the instructors. Hey, if you're an instructor, you like this video, share it. I'm not here trying to make a buck off of this. I want to make sure everyone is safe and understand what's going on with the weather, where this weather data comes from, how to get it, and really how critical it is in aviation. If we could eliminate the accidents that are caused by weather, we could really reduce that general aviation accident rate. So thanks for checking in with us this week on Beyond the Briefing. This is the edition where we are talking about how to ace that private pilot check ride, the weather segment. So until next time, right here Beyond the Briefing, let me know what you think.